Hello guys, so today we will see this question. For the object shown in figure, draw following views using first angle method of projection. First, sectional elevation looking in the direction of arrow X. So front view looking in this direction along sectional AA. Along sectional AA means if we cut this object into two parts along section A, then the cutted part is shown in sectional elevation. Then second is plan means top view, so the top view direction will be here like this, and end view means side view from left hand side, so side view will be from this direction. So for front view, the dimensions are, so in front view means this direction along X direction, the length is this thickness is 18. The thickness of this plate, vertical plate, is 18. Then from this point to this center point it is 60 plus 80, and from center point to extreme left point radius is 18. So 18 plus 18, 36, 36 plus 36 plus this 140. So 36 plus 140 is equal to 176. So we need a length of 176. So first of all, this is we have to draw, in answer we have to draw front view, top view and left hand side view. So if in question side view is asked and it is left hand side view, then left hand side view will be on right side of front view, on right side of front view. See here, on right side of front view. So this area is for front view, this area is for left hand side view, and below front view we will draw top view. So for front view, the area is 18, that is 176, right? 176 mm. By height is, so height in front view is 100. So 100 height is required. For LHSV, center to center distance is 60. Then this distance center to the front line is 16, and again this is also 16. So 16 plus 16, 32, 32 plus 60, 92. So LHSV we required 92 by 100, 92 by 100 area. And for top view we require, so for top view the dimensions are X and this direction. Okay, so this direction is 92, right? So for top view we require (176 by 92). Okay, so now we will draw, we will take this point according to, like, from, so first we will draw a vertical line, then we will draw again same vertical line parallel to previous one at a distance of 1 centimeter on left side as well as on right side. Okay, then we will draw horizontal line, then at distance of 1 centimeter we will draw parallel line to this horizontal line at distance on bottom as well as on top of this line, such that we require this area 176 by 100 from this point. So this area must be 176 by 100 or greater than this area. Okay, so this area must be greater than 92 by 100, and this area must be greater than 176 by 92. Now for front view, we will start drawing from this point. For left hand side, we will start drawing from this point, and for top view, we will start drawing from this point. So first we will draw front view. So in front view, this point will overlap with this point in front view. So from this point, vertical distance is 100 mm, then horizontally 18 mm. Then in front view, we will see this area, this surface, and this cylinder surface, and also this base plate surface. So this 18 mm by 100 mm, and this base plate is of 18 mm height and total up to 176 mm length. Then first we will draw these the projection. The in front view, we see only rectangle of this cylinder. So width of 50 mm and height is of 40 mm from base plate upper surface. So this cylinder axis is at distance of 60 mm from this center point, this circle center point, right? And this circle center point to left extreme point is at distance of 18 mm. So we take 18 plus 60, that is 78 distance from extreme left point, and draw cylinder axis. Then the height of cylinder is 4 cm from base surface. So from this point, we will take 4 cm parallel to this axis. So this is cylinder's front view. It is a rectangle of width 50, that is diameter of cylinder, and height 40. So we will show this axis of cylinder as center line. Then here also it is a cylindrical hole. So from this center point, the center of this cylindrical hole is at 6 cm, 60 mm. So we will mark this point at 6 cm and draw a center line, mentioning that it is a cylindrical hole. And the radius, the diameter of this hole is 18. So we will take 9 mm on both sides. To show a cylindrical hole, we will draw dotted dash line to mention that there is a hole inside of this plate. The center line should come out of this line. Then here it is a stiffener of circular shape. The radius of this stiffener is 80, and the point connecting are these 2 points. So first take 80 mm, 8 cm. Then from this point draw arc. Also from this point draw arc. So this point is the intersecting point. This point is a center point. Now we will draw this arc. So this arc is of radius 80 mm. Now from the center point, we can mention the dimension of the radius as 80 mm. radius 80. Then after front view we will draw top view. So for that we will take projection of vertical lines of front view in top view area. So in top view we can see this surface. Then from center point the diameter is 50. So we take 50 mm diameter. Diameter is 50, means radius is 25. So here this is circle of 25. Then inner circle is 28 diameter, means 1.4 mm radius. Now this circle has a diameter of 80, means radius of 0.9 centimeter or 9 mm. Then these circular holes are at distance, the center of circular hole are at distance 30 mm from this center line, right? From this center line, or 60 mm from each others. So from this center line, these circles centers are at 30 mm on both sides. The circle has a diameter of 80 mm. So from this point we will draw 0.9 mm on both sides. Then this stiffener has a width of 10. So from this point on both sides we will take 0.5 mm. Now there is a slight curve of radius 13, then this radius is 35, then this outer radius is 18. So first we will draw this semicircle of 18 mm, 1.8 centimeter mm, 1.8 centimeter. Then from this point 35 mm, then here this radius is 13, 1.3. So first from this point we will draw arc outside. First we will connect these two arcs. We will draw common tangent on these both arcs. And common tangent up to here. So this line is parallel to this axis y, right? And it is at distance of 30 mm from center line. So from 30 mm it is at distance of 30 mm from stiffener's surface, means this face, stiffener's front face. So from this face 30 mm and draw horizontal line, draw faint line. Then from this point we have taken 13 mm radius, and also so this radius is of 13 mm, right? And we consider this as a quarter circle. As a quarter means 1/4 circle. So considering 1.3 mm and 1.3 mm on this line. So from this point 1.3 mm so this is center point, right? This is 1.3 13 mm and this is 1.3 13 mm. So this will be quarter circle, 1/4 circle. So from this point we have taken 1.3 mm arc, and also from this point 1.3 mm arc. So intersecting point will give center point. From this center point we will draw 1.3 mm arc connecting these two points. Now this is a line. Similarly we will do this for this area, upper area. First common tangent on both curve, then line at 3 mm, 3 centimeter. Then from this point 1.3 mm on both sides. So from this point we require 1.3. mm. This is 1.3 and sorry, this. Okay, so if this is of radius 18, then now we will draw left hand side view. So in left hand side view, the direction of viewing is this. First we will see this inclined surface, right, as a rectangle, then this cylinder as a rectangle, this circular strip as a rectangle, then we will see this surface as it is. Okay. So first we will take projection of horizontal lines of front view in left hand side view and projection of horizontal lines of top view in left hand side view. Center line, circles, diameters, and these plates points. This is the end point. Then this inner circle, its center point, its extreme points, circle's extreme point, center line, and extreme point. Then from these points we will take vertical projection on LHSV area. It seems complicated, but after practice it is very interesting. Okay, so LHS will start from this point. First we will draw this surface first. Okay, so from this point, then also curve started. This curve started. Now this curve is of 16 mm radius, right? So from this point we have to draw, we have to take 16 mm and take its projection on left hand side view to draw a quarter circle. To draw quarter circle, now the center point of this quarter circle is at 16 mm. connecting this point and this point. This is the outer border of LHSV. Then from the center point, draw radius of diameter, draw circle of diameter 18 mm. That is 9 mm radius. Then this inclined surface will show as the rectangle. Center line from both sides of center line we have to draw this cylinders LHSV, that is rectangle. The diameter of cylinder is 50 mm, so we will take from this center line, we will take 2.5 mm on both sides. 2.5 mm on both sides. Up to height 40 mm. Inner cylindrical hole is of diameter 28. So from the center point we will take 14 mm on both sides. Then this circle is here from this point to this point. So from this point, this is line. So this is our complete left hand side view. Only stiffener part is remaining. So position of stiffener is here. So this is a complete LHSV. Then finally we will draw dimensions. So this is a complete diagram. Now we will draw hatching for sectional front view. So for hatching we will exclude the stiffener part. This stiffener part is a support part supporting this cylindrical part and plate. So we will exclude this part, and we will first consider that this 3D object is cutted along this plane section AA. Okay. Then where material is removed, where material is being cut, this material we will show by hatching. So hatching means lines of 45-degree angle and spacing of 2 mm. So this is hatching. Now this is hatching. So we will show this part, this base vertical plate, base plate, this cylindrical area by hatching, excluding this stiffener area, and also this whole area and this area. Okay. You can take approximately 2 mm distance and 45-degree So this is our final diagram.